I built an agent that can query 3.5 million rows of powerlifting data. I'm Jacob, a software engineer and powerlifter, and I've always wanted to combine those two things. What better way to do this than by making tools for powerlifters? And if you don't know what powerlifting is, it's just a sport to see who can squat, bench, and deadlift the most. Here's me squatting over 400 pounds, benching over 300 pounds, and deadlifting over 450 pounds. So I made an agent that can query and analyze the entire sport's history. This is how I built it. So as you can tell by the UI, it's basically Vercel's Next.js chatbot template. For the agent framework, I used Ingest Agent Kit. And yes, I do work for Ingest, but I looked at LangChain and Mastra and a few other agent frameworks, and Agent Kit looked like the least amount of friction. That being said, Agent Kit still has plenty of rough edges, which I'll go over at the end, but we're working on it. For my first run at making this, I streamed the results straight to the front end using Agent Kit's real-time feature, which is basically just a WebSocket. And I saved the chat history to a MySQL database. This led me to quite a few race conditions as the front end relied on the database for the initial chat load, but the WebSocket was supposed to be the method for messages to stream in. So what happens if the WebSocket connection gets cut off before the agent is done with inference? You can imagine the weird state that we can get stuck in because of this. The fix I went with was to go with Convex. The agent would write once to the database, and Convex would push row updates straight to the front end. Now we had one single source of truth, and that whole state handling mess was gone. I mentioned we have 3.5 million rows of data. How do we let an LLM query and analyze that without blowing context? So what I went with was to convert natural language to SQL. I would teach the model the schema in the prompt, and I would let it query the database. The data was in one giant CSV, so I just took that, I threw it in ClickHouse, and I let the model add it. I'll have the prompt linked in the repo below. So AgentKit is based off of this idea of a network, which basically allows you to orchestrate all these agents. So as you can see here, I have 3 agents. One of them is a routing agent, the other one is a query agent, and the other one is a summary agent. For the router, which basically decides if we have enough data or not, I used Claude Haiku. And Claude Code uses a similar technique where they use Haiku for simple tasks. For the querying agent, I use Sonnet. It's really smart, really good at tool calls, as we know. But I saw the Kimi K2 release, which looks kind of cool, so I have to try that out. Once we have all the data, Gemini 2.5 Pro would take the user query as well as the data and make an analysis off of it. As you can tell by the UI, this is more of a proof of concept, so I have a few improvements that I really want to make. The biggest thing is to improve streaming. As of right now, only the final response from the summary agent gets streamed to the UI, and AgentKit's real-time feature only streams the whole final response. So it doesn't actually stream the response in token by token. What I also want to do is I want to stream like the thinking from each agent. So the routing agent has some thoughts, which I can stream to the front end. The query agent has some thoughts between queries that I can stream to the front end. The second big thing I want to work on is to kill latency. The intro was sped up. Inference actually takes between 15 and 30 seconds and sometimes more. But hopefully with like the streaming improvements, time to first token will be really fast so that you're not just stuck there waiting, and it'll feel faster, even though inference can take about the same amount of time. You can try it at strengthsync.app. I'll have it linked down there. But yeah, let me know what you think.